Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this word problem using the concepts of derivatives. So as per the problem, an isosceles triangle is inscribed in a circle of radius r. Find the value of theta that maximizes the area of the triangle. So we are given that this is an isosceles triangle. So this side and this side are equal in length. Now the first step is to analyze this diagram. Now in this triangle, this broken line here represents the height of this isosceles triangle, and it breaks up this triangle into two equal triangles. So as a result, the top angle in these two triangles will have the measure theta and theta. So there's the first concept we need to keep in mind. So let's assume that the center of this circle is here. So we can draw lines from the center of the circle to the corners of the triangle. And these sides have a length of r, which is equal to the radius of the circle. Now we can label the corners in this triangle. So we can draw these sides here. And let's assume the center of the circle is point G. Now we have to find an expression for the area of triangle ACE in terms of theta. So for that, we'll have to break up the triangle ACE into three smaller triangles. So first let's analyze triangle AGC. Now triangle AGC will have an area which is equal to triangle CGE, because in these two triangles, so the top corner angle is the same and the two sides are the same length r and r for both triangles. So that's why these two triangles will have the same area. So if we find the expression for triangle AGC's area, that will be equal to the area of triangle CGE. So let's analyze triangle AGC. So I'll draw it in the same orientation as it is in the diagram. So BG represents the height of the triangle and BG is perpendicular to AC. So let's assume the height of this triangle is H and the distance from A to C is X. So that means the distance from B to C will be X over 2. Now we can analyze the sides in the triangle BGC to find the height and the base of this triangle in terms of theta. So this angle C here is theta. Now we know that the area of a triangle is equal to base length times height divided by 2. So let's analyze triangle BCG. So we can start with the sine ratio. So since triangle BCG is a right angle triangle, we can use SOHCAHTOA. So we know the formula for sine is opposite over hypotenuse. and the hypotenuse CG is equal to R units. The given radius same as AG. So sine theta equals H over R. So if we cross multiply the R, so this is the expression for height of this triangle. Now we can use the cos ratio to analyze the base of the triangle BCG. So the formula for cos is adjacent over hypotenuse. Now we can cross multiply the R. And now we can cross multiply the 2 to get the value of the base of this triangle. Now we can write the expression for area of triangle AGC. So the base is x, which is 2r cos theta, times the height, which is r sine theta, over 2. So now we can simplify this expression. Now in the numerator, we can multiply the r's, so we get r squared, and then and as per the double angle identity for sine, 2 sine theta cos theta can be written as sine 2 theta. So this is the expression for area of triangle AGC. Now the expression for area of triangle CGE is also the same as this expression. Now we can analyze triangle AGE. So we can draw the diagram. Now there's a tricky concept here you have to keep in mind, that in this triangle AGE, the angle AGF is equal to 2 theta. Why? Because for here we have to use a theorem for a triangle. Now in triangle AGC, angle GAC is also equal to theta, because triangle AGC is a isosceles triangle, because CG is equal to AG, both have the length R, and in an isosceles triangle, the angles opposite to equal sides are equal in measure. Now, as per the exterior angle of a triangle theorem, the exterior angle of a triangle is equal to the sum of the two opposite angles in the triangle. So as a result, so triangle GCA plus angle GCA plus angle GAC is equal to angle AGF. So angle AGF is equal to theta plus theta equals 2 theta. So there is a very important concept we need to understand and memorize to solve this problem. Now we can use this information to find the height and the base length of this triangle in terms of theta. So let's assume the height is h and the base length is, so let's assume it's y. So in this case, so a to f will be y over 2. So now we'll have to use the trig ratios. So for h, we'll have to use cos, and the length of the hypotenuse is r, the radius of the circle. So we can cross multiply the r. Now we can use the sine ratio for finding the base length. Now we can cross multiply the r. And now we can cross multiply the 2. So now we can write the expression for area of triangle AGE. So the base length, which is y, times the height, which is divided by 2. Now in the numerator, we can multiply the r's, and we can cancel out the 2 in the numerator and the denominator. So we get so now we can write the expression for the area of the full triangle ACE in terms of theta. So we'll start with area of triangle ACG, which is then plus area of triangle CGE, which is the same as area of triangle AGC, plus the expression for area of triangle AGE. Now the first two fractions can be added. They have the same denominator. Now in the first fraction, we can cancel out the 2's. Now we have to find the derivative of this area expression and then set the derivative equal to 0 to find the theta value at which the tangent is horizontal, because at maximum area or the peak in the graph of area, the tangent will be horizontal. So for that, we can do the analysis on the next page because we'll need some space. So I'll just check if I got this expression right. Yeah. Now we'll find the derivative of this area function, a prime. So in the first term, r is a constant, so r square is also a constant, and it's the coefficient of the term, so it will stay as it is. Now for sine 2 theta, we'll have to use the chain rule. So the outer function is sine, so the derivative of sine is cos times the derivative of the inner function 2 theta, and the derivative of that will be 2 times 1 plus. Now in the second term, r square is a constant, so it will stay as it is. Now here we'll have to use product rule to find the derivative, because sine 2 theta is being multiplied to cos 2 theta. So as per the product rule, we'll start with the derivative of the first function, sine 2 theta. So we'll have to use chain rule because the outer function is sine and the inner function is 2 theta. And the derivative of the inner function 2 theta is 2 times 1 times the second function plus the first function times the derivative of the second function, and the derivative of cos is negative sine, and we'll have to use chain rule because it's a composite function, and the derivative of 2 theta is 2 times 1. Now we can simplify this expression and we can set the derivative equal to 0. So we can factor out r square from both parts. So in the first part we get 2 times cos 2 theta, and in the second part 2 times 1 is 2, and then cos 2 theta times cos 2 theta will be cos square 2 theta, so we get 2, and in the second part 2 times 1 is 2, and 2 times negative sine 2 theta is negative 2 sine 2 theta, and then sine 2 theta times sine 2 theta will be sine square 2 theta, so we get. Now here, in order to get the same trig function in this equation, we should convert sine square 2 theta into 1 minus cos square 2 theta using the Pythagorean identity for sine square theta and cos square theta. Now in the next step, we can distribute the negative 2 in the parentheses. So we get. Now we can combine like terms. So 2 cos square theta and 2 cos square theta, 2 theta are like terms, so we get 4. Now we can factor out a 2 from the equation. So this is a quadratic equation of cos 2 theta. So we can factor this equation. So if we use the crisscross method, so the factors of 2 are 2 and 1. Now we need a sum of 1 because that's the coefficient of the cos 2 theta term. So the factors of negative 1 can be written as, because if we cross multiply, so 2 times 1 is 2, 1 times negative 1 is negative 1, and 2 plus negative 1 is positive 1. So we can put cos 2 theta with 2 and 1 on the left side. So we can rewrite the equation as, so we get two cases. So now 2r square is a constant, so we can ignore it. So our first case is, so we can move the 1 to the right side and that will make it positive. Now we can divide both sides by 2. Now for this area function that we got, the domain is that this angle 2 theta has to be greater than 0 and it should be less than 2 pi or 180 degrees, because the sum of all angles in a triangle is equal to 180 degrees. So if it is equal to 180 degrees, then the other two angles will become equal to 0. So it won't be a triangle anymore. So now we can simplify this domain expression by dividing each term by 2. So 0 divided by 2 is 0. That means theta can be any angle between 0 and pi over 2. So now we have to solve this equation cos 2 theta equals 1 over 2, keeping this domain in mind. So we know that cos of pi over 3 is equal to 1 over 2. And now we can solve for theta by dividing both sides by 2. So the 2's on the left side get cancelled out. So pi over 3 divided by 2 is equal to pi over 6. Because if we write it as a division statement, so I can show it to you on the side. So we get pi over 6. Now we can analyze the second case. Now the cos is equal to negative 1 for the angle value pi. So we can divide both sides by 2. So we get theta equals pi over 2. But as per our analysis for the domain, theta should be less than pi over 2. Because if theta is pi over 2, the triangle will become a straight line, because then 2 theta will be equal to pi or 180 degrees. So this is an invalid solution. That means the only critical number we got is theta equals pi over 6. So that means we have to analyze theta equals pi over 6 to check whether this represents a maximum point. So for that, we'll have to check, we can do the first derivatives test. So we can check the sign of the first derivative on the left hand right hand side of this critical number and see whether the function is increasing or decreasing on the left and the right hand side of this critical number. So on the left side of pi over 6, we can use the angle value pi over 7, and on the right side we can use the angle value pi over 5. So we have to sub in these test values in the derivative expression. So we can use this one. So we can start with the left side. So pi over 7. Now we can evaluate this expression. So we can start with the first term. So 2 cos and then 2 times pi over 7. So I got 1.247. And now for the second part. So 2 times cos squared, 2 times pi over 7. 2 times and now I square it and then times 2. So I got 0.777 and minus now the sine term, and I'll square it and then times 2. So I got 1.22. So this expression will give us a positive value. That means the function is increasing on the left side of this critical number. Now we can do the analysis for the right side. So we should sub in theta as pi over 5. Now we can evaluate this expression. So 2 times cos times 2 times pi over 5. So I got 0.618 plus, so 2 times cos square 2 times pi over 5. So I got 0.191 minus 1.80. Now this expression gives us a negative value. So the first derivative is negative on the right side of this critical number. That means theta equals pi over 6 represents a local maximum. So therefore, we can conclude that area is maximum at theta equals pi over 6. So this should be the final answer for this problem. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.